When we consider integrals of vector functions, we can think about indefinite integrals and definite integrals. We'll start with indefinite integrals. The integral of r of t dt is equal to, by definition, the limit as n approaches infinity of the sum as I goes from 1 to n of r of t sub I times delta t. And just as with derivatives, the limit is applied to each of the component functions. And so I'll just write this using the indefinite integral notation. It's the integral of f of t dti plus the integral of g of t dtj plus the integral of h of t dtk. But just as with indefinite integrals of real functions, with an indefinite integral of a vector function, we have a constant. The constant, however, is a vector. It's a constant vector. And if you think about it, it has to be, because here I have a vector function. It's got components I, j, and k, right? So I can't add a scalar to a vector. If I'm going to add things together, they have to be the same thing. So this is a vector constant. Now, aside from the idea of that vector constant, really, this just says find some antiderivatives and make sure that you tack on the I, j, and k components, or express it using angle bracket notation. Definite integrals are similarly predictable. A definite integral of a vector function would look like the integral from a to b of r of t dt, and that result is going to be the integral from a to b of all of the component functions, so f of t dti plus the integral from a to b of g of t dtj plus the integral from a to b of h of t dtk. And no constant vector for this one, because of course we have definite integrals. We don't write down a constant in that case. And we'll just look at a quick example of a definite integral here. It's going to be the integral from 1 to 4 of 2t to the 3 halves I plus the quantity of t plus 1 times the square root of t k dt. First, I'm going to simplify the k component of the integrand. So this will become the integral from 1 to 4 of 2t to the 3 halves I plus the quantity of t to the 3 halves plus t to the 1 half k dt. All right, looks like we're going to use the power rule a few times here. So we get 4/5 t to the 5 halves I plus the quantity of 2/5 t to the 5 halves plus 2/3 t to the 3 halves. Yeah, that's what I'm going to go with. That whole thing is, oh, that's got a k. Ooh. And the whole thing is going to be evaluated from 1 to 4. Putting 4 in place of t gives us, see, that's going to be 128 over 5 I plus the quantity of 64 over 5 plus, what is that, 8/16 k. Putting 1 in place of t is going to give us 4/5 I plus, I'll go with 16/15 k. I'll just quickly denote what we did with some colors. So we evaluated our vector at t equals 4 and then at t equals 1. And doing that last bit of arithmetic there is going to give us 124 over 5 I plus 256 over 15k. That is how we evaluate a definite integral of a vector function.